let's take a look at the 78 subsets. And what this problem is talking about, we'll be given an integer array numbers, and they are all unique elements, and we need to return all the possible subsets. And what does that mean? Let's take a first example. Like we have numbers, for example, is 1, 2, 3. So what are all the subsets? And now we may probably have nothing, right? Just an empty. Or probably we will have like 1, 1, 2, 3. And this will be size 1, right? And another is we will probably have 2. It's 1, 2, 1, 3, 2, 3. These are size 2. And then we will have probably 1, 2, 3. And this is the size 3. And this is all the possible subsets. But how can we consider this? Right, okay. And definitely we will loop the numbers to think about which number we need to add it into it. And we will have our starting point as well. And let's make a smaller so that probably we have a pretty complexity analyzed. Like, yeah, we have a starting point now. And now let's go to the first level. For example, like if we have only 1 numbers into it, so the sublist size could be, for example, 1. For now, we may probably add 1, 2, 3. And all these results, we need to start to add it to our result list. We can add it, and now we start to construct the size of 2 sublists, and we can add like 2 here, and also add 3 here, and we only can add 3. And for the number 3, we cannot add anything, because if we add 1, it just, these 2's are equal, right? Let's write it down. So for these 2, they are the same, so we should not consider it, and we delete it. Or probably we can write down here, but they are the same. So we should not consider this. And of course, now we are start to construct the size of 3. For the number 2, we can continue to add 3, but for the 3, we cannot add 2. And probably this is the graph that showing us how to construct the subsets, but how we did the loop. Like for example, for the internal loop, let's write it down. For the internal loop in our numbers, we can always add the next position number, right? So we can say loop the number starting from a specific start index, right? And how we can add current number into the sublist. And then we can call the this function again for the next level, right? So we can call this function to explore the next level. And after we explore the next level, for example, if we already explore from this 1 and then to 2, and then we next to 3, we need to revert back to 2. And I'm thinking, can we like add the other numbers, but we don't have other numbers, so we continue to go back to last level to 1, and which is the next one we can add is now, because we already traversed it 2, we can only add the 3, right? And when we are go back here, when we are go back to this level, we come out of this function, and what we need to do is to remove this number. So now we need to just remove the current number, right? So when after we remove the current number, we can continue to explore the loop to the next number is the 3. All right, and now how we decided like when we are return, because there is no specific size of the sublist, so each time when we are travel to current level, we are starting to add sublist to our result. For example, let's say when we are starting to this 1, so we don't care about what the size is, we need to add this sublist already to the result. And then we start to traverse another level is that when we go to here at numbers 2 here, we can also add the number 2 to it. So when we are call this function, we also add sublist. Like we have 1 and 2 here, add this sublist to the result, and then we start to another index to add the number 3 here, and call the function. When we call the function, we have 3 numbers in sublist. We just add sublist to the result, and when we go to loop function, we find that all the numbers are already added, right? We will just skip the loop. So it means that we need to define where we will get into the loop. Is how we decided to get into the loop. Right. And now because all the numbers are already in the loop, we don't care about that. We will just return. We will just go to the end of this function, and then because we already finished this function, we can go back to here and remove the number 3. And then even though we try to for the next one, because there's no next one, we have to go back to last level and continue the 3 to doing that. And then we also go back to here and start to add 2 to come here. So each level we will do add a sublist to the result. So it means that we don't care about the sublist size. Each size we will just add to the result, and we can easily to see the functions. Like this is the whole function, how we traverse the different subside of sublist, the size of sublist, and the internal loop is for loop of the numbers, how we loop the numbers. So this is the whole idea, how we loop in the number and also loop in our different level of this graph. And don't forget is what we do is to add something and also remove something. Alright, so now let's come to the coding part, and we can first of all think about writing this function to help us to construct the subset, right? This function will not return anything because we are passing the list and sublist as our parameters to collect all the possible results, right? And what this way is, we can call it like using backtracking to construct this subset. We can just use backtracking, and we can still have the array numbers, and also we need to define the starting index. And also we will have a result list as well as a sublist when we are creating the subset. Right. So if there are anything we will add later. Okay. So for each level, we will add the sublist to the result. This is what we set at first. And then we'll start looping. But now here how we loop is, if the start index is not out of the boundary of the numbers, it's okay just start the looping. But if already out of the boundary, we don't have to loop it, right? So to reduce calculation, we just pass the length of the numbers. And now it's while the start index is still less than the length, we can start to add our numbers to our sublist. Add these numbers, start index, and we can call this backtrack here, and the original numbers the same length, but the start index will be moved to next one, right? And our result list is still the original one, and sublist is also the original one. And then we need to remove it, size of it. We remove the last number of the sublist. After we remove it, we have to move the start pointer so that it will continue to do the loop. Right. So this is how we create the subset. And now let's go back to the main part. And the main part is definitely we will calculate the length first, numbers length, and then we will have the result list and sublist to initialize these two. Also new array list. Okay, there's a block here. When we are at the sublist to result, we have to copy it. If not, like every time we make changes to our sublist, it will definitely to affect the sublist already added to the result. So here we have to copy it. Alright, and now we can call our backtrack function to pass the numbers, and what's the length is how we calculate, and the start index is from the 0, and also we have the result list and sublist. And after all is done, we can just return our result list, right? And let's check if there are any corner case. Since the numbers list, we at least have no numbers, so we don't have to check the there's no number into it, so we definitely have to start to construct the sublist. All right, and now give some simple examples to it. The starting point is from the 0. When we are start to do it, first of all, we don't have any number into it. We will definitely to add an empty list, and then we start to go to the loop, and we will add 1 into it, and then go to next level. Go to next level, we will add the current sublist 1, and then go to the next level is 2, and also add the 1, 2 sublist have the 1, 2 into it, and the start index now is become moved to here. It's the 2. We can add the number of 3. All right, and I think that's good. Let's run it, run the test case. Looks good, and we can submit it. Good. So here's the thinking process, like how we using the backtrack to construct the subsets, and here's the code. Hope this will help you to how to think about this problem. Thanks for watching.